In the Hypershade window, we can then start setting that up. So, of course, make sure that you're rendering with Arnold. And then we're going to get a shadow matte material. So the shadow matte is here in the shader tab. So just click on it and we get a shadow matte. So the shadow matte shader is specifically made to catch shadows from lighting within your scene. And it is especially useful in that way for integrating rendered 3D objects onto a film footage. So you can, of course, read up on all the different settings of a shadow matte in the documentation of Arnold. So on their website, under the surface, in the shaders section and then surface, we have our shadow matte. And in here you can see all the different inputs and settings of the shadow matte material. And because we're using this matched camera, we can actually texture our shadow matte material with that matched camera. And for that we need another tool, and that is in the utility section, the camera projection. So let's click that. And so the camera projection is going to take the data of our matched camera and use that to project our background image onto this shadow matte shader that we're going to apply on the geometry that we created. So let's put these together. So the last thing, of course, is we need our background image. So in the texture tab, we can take an image. And then let's add our clean plate as an image. So this is our image, and we want the color space to be sRGB so that our gamma is decoded from the image or subtracted from the image. So on our camera projection, we need to, of course, say which camera we're going to use. So in the camera, we can say we want our camera shape, which is the camera 1. And it also needs to get, of course, the image that it needs to project. So we're going to go from the out color into the projection color to make that connection. Now, on the camera projection, you can also see we have this aspect ratio, and it's by default set to 1.33. But if we go to our camera and the settings there, we can actually see that the aspect ratio of our camera is 1.9. So let's change this camera projection aspect ratio also to 1.9. Then we want to project this image onto our shadow matte material. So we want to, on our shadow matte, by default, it is set to scene background. So then if you have an image set as a scene background, it will just take that image and project that onto your object. But you can also just use the background color, and then we can just use that. And so we need to connect this camera projection onto the background color setting of our shadow matte. So we can go from the out color, and now we don't see the background color here, but what we can do is just drag this onto this big button and then just get other, and then we get this input selection dialog box, and then connect it to the background color. So now these are connected. So then we need to apply this shadow matte onto our object. So I select it in the viewport and then just assign material to viewport selection. Now let's also get already a stand-in object that we want to add to our scene. So I'm just going to take a sphere, and in the sphere, in the channel box, we can just quickly set it to a bigger radius and maybe also a bit more subdivisions, and then just place it more in the center of the scene. And then let's get it floating above the air here. And let's get it floating above the floor here, like that. And we want another material on this, so let's get just a standard shader, standard surface, and let's put this a little bit down. Let's add this to our viewport selection, and let's make sure that this is selected, of course. Voila. And then let's make sure that this is, for example, metal so that we can see the reflection. Let's maybe close the hypershade. Let's save this. Let's get an Arnold render view. So if we now render our scene, so make sure that you enable the render and that you have your camera shape selected. So then you can see we get our background image and our sphere within it, and the environment is being reflected in our sphere. So to make it more clear, if we go to our perspective shape and then look at this, so you can see that we can just see that this texture is being projected onto this geometry, and we have our sphere in the middle of it. So it's in this way that we can get those very realistic reflections on the object that we want to add to our 3D to our composite. Now let's go back to our camera shape, and then so you can see in our alpha channel that so all the geometry that we've created will not have any alpha in the final render, but we still have this white on the background. We can get rid of that in the hypershade, in the image plane. Just make sure that the alpha gain of the image plane is set to 0. And so in that way we will also get rid of that, so that in our final render we can just get the object and then eventually also the shadow that we want to add to our scene. So as you can see, we have our object, but we don't already have a shadow in our scene. And that is because there is actually no lighting in the scene yet. We just have that projected image, but it's not calculated light like a dome light or a spotlight or whatever. I didn't record an HDRI from the scene itself, but I'm just going to use another HDR from the internet that is just similar in lighting, and just use that as a light source here. This website is a very good resource for HDRIs, hdrihaven.com. And so here I looked just for an HDRI of a very cloudy day, and I found this, the Whipple Creek Regional Park 01. So I downloaded this, and as you can see, you have many different resolutions, but if you're just using it as lighting and you don't have very reflective materials where you go close to with the camera, you can get away with lower resolutions. If you have very sharp reflections and you want to have those appear realistic, you need to have more resolution. So then you have to download these higher resolution HDRIs. To add this into our scene, I'm going to use an Arnold dome light, sky dome light. So that adds this dome shape to our scene, and you can make it a bit bigger in the sky dome light shape, and then under viewport, the sky radius, let's put this to 5000, for example. So to get a little bit of a bigger dome here. And then in our hypershade, I want to, let's just make a new tab here, and I want to import a texture, of course. And then let's get our image here. So I've downloaded a 2K HDRI, and so we can load this .hdr file then into our image. Then we can also get our sky dome node. You can find it in the lights tab here in the hypershade, and then just connect the color to the color input of the sky dome light. Also very important when you are working with HDRIs, they are in linear space, so we need to tell to the image node that they have to import it as raw, so there is no gamma encoding subtracted from this image. Also, you can check this box, ignore color space file rules, so when you re-import it, it will stay just on this setting. So if we now render this again, we get this result. So now you see that we get some shadows here on the floor. So the HRI is from a very cloudy day, so it's quite difficult to see where exactly the light is coming from. But for this, I'm not going to bother trying to figure out exactly what is the right position of the HRI. I'm just going to leave it at that. Maybe I turned around it a little bit. If I check on the sky dome light, and then in the transform, yeah, so it's rotated 180 degrees, but I didn't really see that much difference. No, there's really not much difference. But you can also just look at what kind of reflection maybe you would like to have. That we have the shadow here on the floor is perfect, is what we want. But you can also see that there are shadows added on parts of our projected image, and that is definitely not what we want, because the image that we're using as projection is already lighted just from where it was filmed. We only want lighting to hit our object and to get the shadows that are projected from that object onto then the scene geometry that we made. We can prevent that by clicking on our plane, and then on the plane shape, and then in Arnold, we here have some general options of which rays we want to exactly have in our render result. And this is the one that we don't want, self shadow. So that means that lighting is hitting the object and then casting shadow onto itself. We don't want that. We do want, of course, to so if we would have another lighting situation where there would be more sunlight coming from behind this wall, and that it then would cast a shadow onto this wall, that we would want. So we want it to cast shadow, but we don't want to self shadow. And you see, if I disable this, this gets completely cleared up, and we're just left with this shadow that's being projected beneath our sphere. If I now go to the alpha channel of this render, so you see that we get our object that we have, and also the shadow that is added. We get some alpha there, so that is very good. But we do have this white background again, so we need to get rid of that. And ideally, we want this background to just be black, because we don't need any of that in our comp. And as you can see, we actually have a little bit of HRI here, and then also in the background, our background plate. I don't know exactly the reason why it is showing like that, but we just want to get rid of both. So this top part, the background image that is not projected onto geometry, will probably be from the camera plane, from the image plane. So if you just go to the image plane and just set the color gain to black. So maybe we can just drag this slider all the way to the left. So that gets rid of that. And then we also want to get rid of our HRI here. And we can do that in the sky dome light. So in the sky dome light, we have these visibility settings as well. These are others than on the plane, but yeah, it's a similar kind of settings actually. But then on the sky dome light, we just want to disable our camera rays. So the camera rays are the ones that are direct between our HRI, our sky dome, and the camera. All the other rays that are coming from the HRI are actually reflected in our object. So those would be in the specular channel. So if we set the camera to 0, so only the direct rays between the camera and from where the sky dome comes from are situated in these camera rays. So if we now render this, this should be black. And so now we're just left with our projected image and our added object and the shadow, and the only information that is in our alpha channel is actually where the object is and where the shadow hits. So that means that when we merge this, it will not get all this other color information from our camera projection. So let's now change the shader of our 3D object. We don't want it to be a metal, because then we would have also reflection of the character visible into this. So we can in some ways try to achieve that, but then we would also definitely want some breaking up of the reflection, because it's not going to be easy to get it perfectly right. But let's for now just don't make this the metal shader, and let's just put this down to 0 on the standard surface. So let's put this shader, the metalness, to 0 again, and let's make this color, the base color, maybe a little bit more dark gray. So if we render this out, we get this sphere here that is still reflective but not metal. So we can now start thinking about rendering this out to add it to our composite. And there's still something that is quite important to get a good quality render with this kind of setup. And I can better show you if I go to the alpha. So if you look at this shadow that's being projected, you see that there's really a lot of noise here. And that is because on our Skydome light, it is, to get this better, you'll probably need to increase these samples. So if I just get a render region here, and then let's just increase these samples to 4. So you see that immediately we get a lot better quality in our shadow. So let's maybe increase this even a little bit more, not to 46, but 6, for example. And then also in our render settings, of course, we can maybe get a little bit more diffuse samples, a bit more specular samples, transmission, subsurface scattering, and volume direct can become 0 because we don't have that in our scene. And then maybe the camera AA also a little bit extra. And that way we can get a rather clean render here. So if I then go back to our alpha channel, you see that that shadow is much more cleaner than what we have here. So let's get rid of our render region and let's just render this. So this image is now rendered. I'm not going to set up a normal render with AOVs and such. I'm just going to export this render now from the render view. So we can just save the image, and I'm just going to save it in my 3D scene folder. And this is my 3D scene. And I'm going to save it as an EXR.